If the diver goes to the surface too quickly, the nitrogen won't be absorbed by the diver. Nitrogen narcosis brings on a type of high.
Decompression sickness is surfacing too fast, making the body get rid of its nitrogen. A diver would dive down a little ways and rise back up, but slower the next time.
To get over it. Not keeping an eye on your pressure gauge when you're diving down would be a huge concern. Another would be to watch how long you're down before you run out of air, and then ascending too quickly would be the last dangerous thing. Right now, we're filling up the bottle to over halfway. Now we're filling the dropper up to halfway, as you can see here. Now, I'm going to drop it in the bottle, which you just saw, and then we're going to fill it up right now. Right now, the dropper is to the lid because of the air bubble that is in the dropper with the water. Now Kenzie is applying pressure, thus making the air bubble inside of the dropper smaller so it falls to the bottom of the bottle. What kind of changes in pressure is a diver subject to and why? The diver is subjected to pressure changes when you get closer to the bottom of the ocean because the floor pressure is bigger and the oxygen supply gets smaller. The pressure gets bigger because you're getting pulled closer to where gravity pulls everybody. Right now we are boiling water inside the can until it's about gone so that way the can warms up enough. And right now we are picking it up and putting it into the ice like the instructions say to do.
So the reason why the can behaves is because the two volumes, the can and the air, are unequal. So the less one, which was the can, got crushed by the bigger one, which was the air. The diver is subjected to colder water the further down they go. Because of Charles' law, the colder the water, the greater the pressure because there is not much volume
of the water.
I don't even know what the pressure is because
you can't really see it.
Then we created our little cloud. So which law is this? Did volume change? Of this bottle didn't. So what we're doing is messing with pressure. And then we know the temperature changed because what happened inside the bottle? Condensation. So
all right. Change the volume inside the balloon, right?
Change the volume inside the balloon. So now this is kind of you got two different laws going on right now. You got Boyle's law going on with the balloon because I'm increasing the outside pressure, and what's happening to the volume of the balloon inside?
It's technically shrinking.
It's going down, but as soon as I release the pressure,
it all comes right back.
The volume goes back. But then inside this bigger bottle, we got P over T, which is that? That's Guy-Lussac's law. Because we're changing the temperature, we're changing the pressure of the whole system, and so the temperature changes with it.
The balloon shrinks in this experiment because the pressure outside of it becomes bigger, so the volume of the balloon is forced to become smaller. A diver needs to know this because the pressure in the ocean is bigger, so the volume of the diver's air supply is forced to get smaller.